Hello everyone, and welcome to Earth Archives. Do you know what we're going to talk about today? It's said to be super mysterious and mind-blowing, black holes.
Black holes aren't just the terrifying, devouring monsters from sci-fi movies. They really exist in our universe. And they're even more incredible than you might imagine. These cosmic gravity monsters have such powerful gravitational pulls that not even light can escape. Once you get close, it's like entering an abyss of no return. But did you know? Black holes aren't fictional. Scientists have confirmed their existence through years of observation and theoretical research. Black holes usually form from the death of massive stars. When a star runs out of energy and undergoes a supernova explosion, its core collapses under its own gravity into an infinitely dense, extremely small singularity, surrounded by the famous event horizon, a boundary beyond which even light cannot escape.
Really? I always thought black holes were super far away and dangerous. They suck in light and even slow down time. What exactly are they?
Do you know what a black hole is? Simply put, it's one of the most extreme and incredible objects in the universe. Black holes have huge mass and incredibly high density, with gravity so strong that even light cannot escape. This means that once something gets too close, no matter how fast or energetic it is, it will be completely swallowed, without a trace. Imagine falling into an incredibly deep pit. No matter how hard you climb or how fast you sprint, you can never escape. That cosmic trap is a black hole. Unlike stars, it doesn't emit light, and unlike planets, it doesn't reflect sunlight. Black holes themselves are completely dark, but scientists can indirectly detect them by observing the motion of nearby matter, intense radiation, and even gravitational waves.
Wow, so how is the boundary of this pit defined?
Black holes are among the most mysterious and extreme objects in the universe. You might have heard their name, but do you know what their most terrifying and irreversible feature is? That's the event horizon. The event horizon is an invisible boundary around the black hole. Once you cross this line, whether it's light, matter, or even information, nothing can ever escape. You can think of it as a one-way gate in the universe. Once you enter, the journey only goes in, never out. And deeper inside the event horizon lies an even stranger entity, the singularity. This is the heart of the black hole, but scientists know almost nothing about it. Inside the singularity, density approaches infinity and volume approaches zero, and all known laws of physics break down. This means our current science simply cannot describe what's happening there. It's like a mathematical error point that defies all our understanding of time, space, and matter.
So the photos we've seen of black holes, are those actually the black holes themselves? I remember in 2019 they said they took the first photo.
April 10, 2019, was a groundbreaking day for humanity's scientific community. It was the first time we saw the shadow of a black hole. The photo featured a supermassive black hole at the center of the galaxy M87, about 55 million light-years away. Its mass is 6.5 billion times that of our Sun, and its diameter exceeds 40 billion kilometers. Just imagining its size gives you goosebumps. This black hole is so huge it could cover the entire solar system, and is even 3 times larger than Pluto's orbit. The photo was taken by the Event Horizon Telescope (EHT) collaboration, which combines radio telescopes around the world. It's not a normal optical image, but a composite made from radio wavelengths, piecing together electromagnetic signals emitted by the accretion disk around the black hole. The ring of light in the image comes from hot gas being pulled and heated by the black hole's gravity. The dark circle in the middle is the black hole's event horizon. Once something passes inside, not even light can escape.
But black holes don't let light escape, right? So how can we actually see them?
Black holes, the most mysterious and extreme objects in the universe, are often imagined as monsters that swallow everything whole. But in reality, The famous black hole photo taken in 2019 isn't an image of a black hole itself, but of its surrounding accretion disk. This detail is fascinating and reveals the mysteries behind how we observe black holes. The accretion disk is a ring-like structure made up of huge amounts of gas, dust, and other matter. Due to the black hole's powerful gravity, this matter spins and rubs together at extremely high speeds, generating intense heat. This hot material emits bright light and various electromagnetic waves, allowing us to see their presence from far away. When this light is blocked by the black hole's event horizon, it creates the black hole's shadow, the dark circular shape seen in the photo.
I see. So how was this photo taken? Can ordinary telescopes capture it?
Black holes are so mysterious and distant that ordinary optical telescopes simply can't observe them directly. The key tool behind the 2019 black hole image is the cutting-edge technology called the Event Horizon Telescope, EHT. It's not a single telescope, but a global network of 8 radio telescopes. These telescopes are spread out around the Earth, from the Antarctic ice, Chile's mountains, to the volcanic peaks of Hawaii, spanning both hemispheres. Using a technique called Very Long Baseline Interferometry, VLBI, they synchronize the radio signals they receive with extreme precision. It's like linking 8 telescopes into one super telescope with a diameter the size of the Earth, giving it unprecedented resolution. During observations, these telescopes simultaneously target the black hole, collecting faint radio waves emitted from tens of millions of light-years away. Powerful supercomputers then process this massive amount of data, perfectly stitching together the signals scattered across the globe, reconstructing the shape of the accretion disk and the black hole's shadow. This technological breakthrough is not only a milestone in astronomy, but also marks a new era where humanity can directly witness black holes.
Wow, so the resolution must be incredibly high, right?
The resolution of the black hole image is absolutely beyond imagination. It's considered one of the most astonishing visual achievements in human history. The image captured by the Event Horizon Telescope, EHT, had such an extraordinary resolution that it's been compared to being able to see the details on a coin on the streets of Los Angeles while standing in New York City. This level of clarity finally allowed us to see what was once only imagined in theory or science fiction. To achieve this breakthrough, scientists conducted many nights of observation, coordinating 8 radio telescopes around the world and patiently collecting trillions of data points. Through extremely complex calculations and data stitching, they reconstructed the glowing ring around the black hole and the dark shadow at its center. That dark area is the black hole's event horizon. Once light or matter crosses this boundary, it can never escape.
So, the glowing ring in the photo is actually the light coming from the accretion disk?
Exactly. A black hole itself is completely dark because its gravity is so strong that even light can't escape, which means we can't directly see the black hole. So how do we see it? The key lies in the accretion disk that spins rapidly around it. This disk is made up of enormous amounts of gas, dust, and other matter. Under the black hole's intense gravity, this material spins at extreme speeds, causing intense friction and heating up to millions or even tens of millions of degrees. These extreme temperatures cause the accretion disk to emit X-rays and various other forms of electromagnetic radiation, making it the most important signal we can detect to observe black holes. In 2019, the EHT successfully captured the image of a black hole. In that image, the dark circle in the center represents the event horizon, the boundary of the black hole. Once anything crosses this limit, not even light can escape, which creates the deep black shadow in the photo. Surrounding the shadow is the bright ring of light emitted by the superheated material in the accretion disk.
Black holes are so mysterious. What's the history behind their study? I think I've heard of something called a dark star.
The concept of black holes actually appeared much earlier than we might think. Back in 1783, renowned British scientist John Michell proposed the idea of a dark star, which can be considered the earliest prototype of the black hole concept. Michell suggested that there could be celestial bodies in the universe with gravity so strong that even light could not escape them, making them invisible to the naked eye. This forward-thinking idea not only challenged the scientific understanding of the time, but also laid the groundwork for the later development of black hole theory. At the time, physics was still based largely on Newton's theory of gravity, and light was thought to consist of tiny particles with mass that could be influenced by gravity. Using this theory, Michell reasoned that if a celestial object had enough mass and a small enough volume, its gravitational pull could become so intense that even light couldn't escape. Although the idea of dark stars wasn't widely accepted at the time and lacked observational evidence, it was undeniably a pioneering step in the evolution of black hole theory.
So how did Einstein get involved?
In the early 20th century, Albert Einstein proposed his groundbreaking theory of general relativity, which completely revolutionized our traditional understanding of gravity. Before that, gravity was seen as a mysterious force that acted instantaneously at a distance. But Einstein's theory revealed that gravity is actually the result of space-time being curved and deformed by massive celestial objects. This entirely new perspective not only provided a deeper explanation of planetary motion, but also laid a solid scientific foundation for black hole theory. To understand gravity in the context of general relativity, imagine a flat bed sheet with a heavy ball placed on it. The sheet will dip under the ball's weight. Now, if you place smaller balls on the sheet, they won't roll in straight lines anymore, but will instead move along the curved surface created by the dip. This visual metaphor helps illustrate how space-time bends due to mass, and how that curvature affects the motion of objects. It's a simple analogy that makes the abstract structure of space-time easier to grasp.
So what breakthroughs did later physicists make?
Black holes, these mysterious and powerful celestial objects, are the result of the accumulated wisdom and effort of countless scientists. One key figure was Carl Schwarzschild, who in 1916 introduced the concept of the Schwarzschild radius, forming a crucial theoretical framework for the black hole's event horizon. The Schwarzschild radius defines the critical boundary a celestial object must be compressed within. Once it's smaller than this radius, its gravity becomes so strong that not even light can escape. This forms what we now call the event horizon, essentially the edge of the bottomless pit that is a black hole. In addition, Subramanian Chandrasekhar, an Indian-American astrophysicist, made major contributions to our understanding of stellar evolution and collapse. He discovered that when a massive star runs out of fuel, the internal pressure can no longer resist gravity. The star collapses inward, forming an incredibly dense point, the precursor to a black hole.
So from dark stars to general relativity, and now actual photographs, black hole research has taken over 200 years?
That's right. For a long time, black holes were a mysterious theoretical concept in the minds of scientists. Starting with the earliest mathematical models, then propelled forward by Einstein's general relativity, and later refined by Schwarzschild's theory of the Schwarzschild radius, scientists gradually built a theoretical blueprint of black holes. However, for decades, these ideas remained abstract and unconfirmed, living mostly in equations and speculation. That changed in 2019 when the Event Horizon Telescope EHT, a global collaboration involving 8 radio telescopes, used very long baseline interferometry (VLBI) to capture the very first image of a black hole's shadow. The image shows the supermassive black hole at the center of the M87 galaxy, about 55 million light-years from Earth. This achievement broke through the limits of human observation and transformed abstract theory into a real, visible marvel of the universe.
So it sounds like black holes don't just suck in matter, they also affect time and space.
Exactly right. When you approach the event horizon of a black hole from the perspective of someone watching from Earth, your time would appear to come to a complete stop. But to you, time would still feel like it's passing normally. This strange phenomenon is known as time dilation, and it happens because the immense gravitational field of a black hole warps space and time. Due to a black hole's extreme mass and density, its gravity is powerful enough to distort the fabric of space-time, making time and space behave in ways that are completely unfamiliar to our everyday experience. Time dilation means that a clock near a black hole ticks more slowly than a clock farther away. This prediction comes straight from Einstein's general relativity, and it has been experimentally confirmed in many ways. If an astronaut were to approach the event horizon, they would still perceive time passing normally. But to an outside observer, the astronaut's movements would appear to slow down dramatically, almost as if frozen in time. And it's not just time. Space itself becomes warped and unpredictable near a black hole. Inside the event horizon, the normal rules of physics, as we know them, completely break down. Space is no longer a smooth three-dimensional landscape. It becomes highly curved, twisted, and distorted. This makes black holes the most mysterious and elusive objects in the known universe.
What would actually happen if someone fell into a black hole?
The extreme gravity of a black hole is almost beyond human comprehension, and its immense gravitational pull creates astonishing stretching effects on objects that get too close. Scientists call this phenomenon tidal forces. It's similar to pulling on a piece of spaghetti. Your body would be stretched lengthwise and squeezed thinner, a process known as spaghettification. As you slowly approach the event horizon of a black hole, these tidal forces grow stronger and stronger, ultimately pulling you toward the mysterious core, the singularity. The singularity is the very center of the black hole, where density becomes infinite and volume shrinks to zero. It's a place where all known physical theories completely break down. Scientists know extremely little about what truly happens there. It might be a gateway to an entirely new realm of physics, or it may hide the deepest secrets of the universe. At the singularity, even light cannot escape, and space and time are warped to their absolute limits, becoming a state that lies beyond our current understanding of reality.
What is the scientific significance of the black hole photo?
On April 10, 2019, a truly historic moment in the history of science took place. Humanity captured the first ever real image of a black hole's event horizon. This wasn't just a photo. It was a powerful confirmation of Einstein's general theory of relativity, turning what was once purely theoretical into a landmark of experimental evidence. The black hole, long seen as one of the most mysterious and elusive objects in the universe, finally appeared before our eyes in a truly awe-inspiring way. The image shows a bright ring of light, which is emitted by the accretion disk of hot gas and dust swirling around the black hole. At the center of this ring lies a deep, dark region, the event horizon. Once something crosses that boundary, no matter or light can ever escape. This image not only confirmed the existence of black holes, but also validated Einstein's theory of space-time curvature, beautifully linking theory with direct observation.
So, what does the black hole have to do with the future of the universe?
Black holes are among the most mysterious and powerful objects in the cosmos, formed in the final stages of a massive star's life. When a star exhausts its fuel, its core collapses under gravity, forming a region of incredibly high density and immense gravitational pull, a black hole. These black holes continue to consume surrounding gas, dust, and even stars, having a profound impact on the evolution of galaxies. In a way, they're like cosmic devourers that shape the structure of the universe. Over time, supermassive black holes may come to dominate the centers of galaxies, and possibly even influence the fate of the universe itself. Their gravity is so strong that they could draw in and consume nearly everything nearby, gradually leaving behind a cold, dark, and silent universe. It's a future that is both awe-inspiring and haunting. But black holes are not eternal. The famous physicist Stephen Hawking proposed the theory of Hawking radiation, suggesting that black holes slowly evaporate through quantum effects and eventually disappear. Although this process is incredibly slow, far longer than the current age of the universe, it provides a new perspective on the ultimate fate of black holes and deepens our understanding of how the universe itself might one day end.
Wow, so could the universe eventually become a kingdom ruled by black holes?
Black holes are not only the most mysterious celestial objects in the universe, but also a crucial starting point for scientists exploring its deepest secrets. Theoretically, black holes are formed by the collapse of massive stars, possessing gravitational forces so intense that even light cannot escape. However, black hole research goes far beyond that. It has inspired scientists to delve into dark matter and dark energy, and even led to the proposal of multiverse theories. In this sense, black holes have become the ultimate testing grounds for the limits of modern physics. The extreme environment around black holes forces us to re-examine the very nature of time and space. Near the event horizon, time dilates due to gravity, creating the unimaginable effect of frozen time. Space is also warped to an extreme degree, pushing the boundaries of what we traditionally understand. These phenomena are not only challenges for scientific theories, they also offer profound insights into the nature of existence and the fundamental structure of the cosmos.
That's incredible. Black holes are seriously cool. I wonder, if technology advances even more in the future, could we ever probe inside a black hole?
With the continuous advancement of technology and observational methods, scientists' understanding of black holes is gradually deepening. What's even more exciting for the future is the possibility that we might truly unveil the internal structure of black holes and further comprehend the essence of these cosmic giants. Through more precise telescope arrays, more advanced mathematical models, and increasingly powerful detection technologies, scientists hope not only to clearly map the outer contours of black holes, but also to probe their internal mechanisms in depth. This effort is not just about understanding black holes themselves. It's also about using black holes as a key to uncovering clues about the origin of the universe. Black holes might serve as bridges connecting the high-energy state of the early universe with the cosmic structure we observe today, helping us unlock the mysteries surrounding the birth of the universe.
Awesome. I'll go ask everyone in the comments if anyone wants to join in discussing the mysteries of black holes. Black holes aren't just sci-fi, they're a mind-blowing reality of our universe.
Exactly. We're looking forward to seeing more people join the conversation, exploring black holes together, and feeling the infinite wonder of the cosmos. Black holes aren't some distant fantasy. They're waiting for us to gradually unveil their mysteries.
Alright, that's it for today's black hole adventure. Everyone, don't forget to subscribe, share, and leave a comment telling us which secret of black holes you're most curious about. Next time, we'll dive deeper into the universe and explore even more unknowns.
Absolutely. This is just the beginning. There are so many more cosmic miracles waiting for us to discover. See you next time.